welcome. I'm Luca. I'm the CTO of Robotics, and I've been here since beginning of 2009. So I've seen a little bit all the changes and evolution of Robotics as a company. So I studied the robotics in the university. So actually, no, this was my big dream, to find a place, a company where I could do what I like most, that is developing robotics from mechatronic, from software point of view, and building useful robots. And actually, I started getting involved in robotics because one of my activities during the study was also participating to RoboCups, to competition, and is where I actually get involved into the Linux open source software and collaborating with different universities. So it was really nice. I started traveling for competition to Japan, to a different place in Europe, and I saw that there was a lot of growing in this community. Then after the master, I started working in a big company, Fiat, in Italy. Engineering and design is a super huge department in Fiat that is doing everything that is related to design, conceptualization, and electronics for the car industry. And there were things that were really interesting, because you see also the cars inside are robots. Even if they at the time there was not yet the interest in autonomous navigation, there were already a lot of robotic components. I was mostly involved in robotic gearboxes, and also everything that then converged to what is now the start and stop functionality, so that the car starts switch on and switch off depending on the conditions. So at the end there was a huge state machine and sensors and really a lot of logics and intelligence in that, and was really nice. But then I got a little bit I wanted to go back to a smaller company, because the big companies is nice, but the dynamics are slow. Everything is, especially in these big companies, all the development is done by suppliers. You are only providing requirements, or you are too many meetings and not that much hands-on. So I started looking for an opportunity, and I found Robotics, and they offered a nice let's say ecosystem, small company, software development, humanoid robots. I couldn't believe that that was even possible, and I moved to Barcelona. And then since then many things have changed. From software, at the beginning I was mostly involved in navigation software development, then more control about locomotion, motion planning, then more closer to electronics, real-time control, and then from that I also started supervising the, let's say, electronic and mechanics design and activities. And now since more than 7 years almost, I'm CTO. CTO in a company at Robotics, do a little bit of everything. Especially I try to understand all the dependencies of the many activities, tasks that we are doing from technical point of view, and trying to, it's like a puzzle. And at the same time, I'm also really active outside Robotics, giving talks outside. I'm traveling a lot when it was possible. Now the last 2 years has been a little bit more complicated, but I like a lot to travel, to visit fairs, conferences, because it's where I got ideas, or where we discover interesting opportunities for collaboration and new projects. And should I use this one? Okay. Then a little bit overview of the presentation, the company, the first robot that we developed, and then going a little bit more in detail about the software and what we do in terms of activities for European projects, development of some of the platform, and then also the competition. Our company. So the company, I don't know how much you know about the company, was started in 2004 by 4 guys, 2 Italian guys and 2 Catalan guys. I don't know what happened. I clicked where I didn't want to click. Okay. 2 Italian guys. One was Davide Fagonti, the original founder, that was an Italian electronic engineer that was having the PhD in Brussels, and he got contacted by a company in the UAE that wanted to build a humanoid robot, and nobody in the world at least they contacted many universities, many engineers, but nobody accepted the challenge apart from Davide. And Davide was a really good friend of Francesco, and they decided to come to Barcelona because they liked the city. They never visited the city before, but they heard that Barcelona was a nice place to start a company. So they come here, and they found two other guys in UPC, the Polytechnic of Catalonia, the University in Catalonia, and they started the company for people. And in few months, like 8-10 months, they managed to have the first prototype. That was the remake, and then everything started from there. So then they managed to have more funding for another prototype, and so on and so forth. So everything started like step by step. Now the company is, let's say, a little bit more complicated than that. We have different, we call them a business unit. So business unit for us is a vertical that is, let's say, segmented depending on the type of customers or type of market, the application that we want to reach. And this is something that we started, let's say, organizing, especially for making people from outside understand what are our, let's say, plans for the future. So we believe that robotics is gonna reach every aspect of our daily life. But especially as of today, there is a clear segmentation of what is a social robot, what is a humanoid robot, what is a mobile manipulator, or what is a more industrial or, let's say, intralogistic robot. So now, let's say, you can think of humanoids as only a research platform, and is it true? We are a selling platform for doing research, and especially in terms of customization, software development, or after sales service and maintenance. It's quite a tough job, because this kind of robots are very complex, they are fragile, they need continuous maintenance, and we are providing this service. So we are providing to the university or research center platform that they can use for their research without worrying about, you have a model that is broken. Okay, don't worry, we are going to replace it. The software migration to the new version of ROS is taking a long time. We are doing for you. The simulation is not working. We are going to fix the simulation. So it's like we want to give researchers and universities only the time that they need for doing research, not for building the tools that they need for the research. It's like a little bit, I always do the comparison with the computers industry or computers ecosystem in the 80s, where big universities like MIT, Stanford, they had this super large computer that then they shared with the researchers. And it's a little bit like this, because these are expensive robots. So one Talos is a 1 million robot, and it's not something that all the university can afford yet. But for the moment, they are using it for doing research. We have quite a good community around humanoid robots. We have sold several units in Europe, but also in the US, Canada. And we are seeing the results. Just yesterday, there was a final demonstrator of one of the most important European projects that we have with humanoids. And we demonstrated the robot climbing stairs, manipulation with whole body MPC. That is something super fancy and super challenging. Also, we are bridging the gap between learning and control. So there are new developments that have been possible thanks to the effort on using common platform, because in this European project, for instance, we were using one robot of Robotics, one Talos in Toulouse, and one Talos in Edinburgh. So thanks to having the same platform in 3 different centers, we managed to advance a lot. Then for social robotics, there is a huge interest in community in having robots that have embodied intelligence. We believe that having a humanoid shape, or at least expressiveness from a robotic point of view, is much more communicative, or we can create much more interest and engagement with the user. So we have been exploring the social human-robot interaction and social robotics application since almost the beginning, because the first, let's say, application of the humanoid technology actually was a wheeled humanoid robot, the RIM robot that we launched in 2010, 2011. And then mobile manipulation, because also for us, the evolution of mobile and industrial manipulator is adding mobility. And but for the moment, the most ready solution that we have for industry are based only on autonomous navigation and wheeled robots. Especially, We have a lot of success with the Stockbot that is for autonomous inventory taking in retailers that use RFID technology. So the robot navigates autonomously in the corridors and scans with RFID antennas all the environment that provide the continuous inventory control with all the also location of the items in the shops. And then we have several other configurations with same mobile base, but with different accessory on top, from conveyor belts, from shelves, and different type of accessories. And then this is a little bit the evolution of our, let's say, portfolio of products, even if they are not products, because many of them, especially, are always customizable. You can add the sensor, you can add different end effectors, but you can see also that we are quite diversifying the portfolio. So we have from small mobile bases up to full-size humanoid robot, and then most recent, let's say, I would say advanced legged system, in which we are exploring also smaller size robot with a solo quadruped, but also more, let's say, performance or agile robot with Kangaroo. That is a concept with a complete different actuation system that we would like to use for demonstrating electronic actuators capabilities in terms of jumping, running, and even resilience to faults. The first robot started very many years ago in 2004. The company was in a flat in Barcelona, a typical Champla flat. I remember that I did the interview in that flat, and they were famous because they had these videos of a humanoid robot walking in front of a fireplace. Because was let's say the room dedicated to experiment was the one with the fireplace in the flat. And so it was, I mean, really like nice startup environment. Few people in the company that were working many hours, and they managed to build this prototype that they remade. That was quite astonishing, because at that time only Asimo from Honda was demonstrating autonomous walking in flat surface, and the robot was super nice in terms that it was 40 kilograms, really lightweight. And they then started traveling a lot. They went to Los Angeles, San Francisco, US, for trying to get funding, for trying to get more let's say, new projects. And then thanks to the success of Remake, this is Francesco, almost 20 years ago, that now is the CEO of Robotics. And then after the Remake came the Remake, the name were not that original at the time. So they always added a new letter. The Remake, the main difference is that it was way more powerful in terms of actuators, especially for the upper body, and also in terms of sensor, because they started working about autonomous perception and manipulation of objects. And then the project ended with a big event in UAE, in which they presented the robot in front of the government, of the sheikhs of the United Arab Emirates. And there was actually also, the robot was autonomous without crane on the stage, was doing the demonstration in front of the audience. There was a huge press coverage. So that that moment, I think that is one of the critical moments of the company, because thanks to the success of that event in UAE, then Robotics started as a commercial company. Until the end of 2008, the company was only dedicated to R&D. There was no the idea of commercializing the technology or looking for customers. It was only R&D, pure R&D. But then we started looking to commercial application. Okay, so the first thing that came to the mind of our founders was that, okay, we know how to build a humanoid robot, but then with the legs it's going to be complicated. It's nobody is going to buy a robot with legs at this moment in time. So okay, let's put mobile base on the lower part of the robot, and let's look for application in which it could make sense. And even because of the, let's say, interest, especially in the UAE, the idea of having a Remage is for Rim Hotel. So the idea was that the robot was a dynamic information point, autonomous guide, interactive service robot for public spaces, especially museums or hotels. And we started with this prototype that was a little bit, let's say, I would say, retro, because of the color. Actually, we got the inspiration by some movies but it was nice, but still was really expensive. And then we found the limitation of the, let's say, both software architecture or functionalities, because at the end the robot was an expensive toy with few functionality, and the interaction was not really fluid with the users, so was not successful. We didn't manage to sell many units of this, but we did a lot of experiment, especially with the next prototype, the RIM series of robot. We did like 100 events every year. We were traveling a lot. We got a lot of feedback and press coverage, and that helped at least understanding what we did wrong. And then the new prototype started. Also, that still had the limitation because it was still expensive, and but then helped a lot in shaping, let's say, the technology that we're using, because at that time there was no ROS, there was no 3D printing, there was many of the technology nowadays we are using and that are, let's say, accessible and help us prototyping quickly. Functionalities were not present yet, so we started looking around and we found interesting technologies. These are the specification of the first robot. I mean, it's not really interesting, but I think that a little bit the lesson that we learned that, okay, you can do complex machine, you can do a complex software architecture, but then you need to maintain it. You need to really spend a lot of time in small details, and that is gonna move your focus away from the real problem that we want to solve. So the lesson, I think, is that from one side you need to simplify, but also then you need to understand where to invest time, money. And so we started going a lot from a software point of view, and especially thanks also to our involvement in the ROS ecosystem. And we started adopting ROS since almost like second or third release of the software in 2010, 2011. We started also understanding how to modify ROS, or what was missing also in ROS, because then not all the user of ROS had the same issue that we had about quality, about real-time control. So this is a little bit the ecosystem of tools that we have been using, that we are still using nowadays. So ROS is one of the big, let's say, block, because all our robots are ROS compliant. Then we have the simulation in Gazebo that is also, let's say, available open source. Everybody can evaluate our robots just downloading from GitHub the URDF and the launch file for simulation. ROS control was an important building block, because with this we managed to have the combination of real-time control that we needed for many degrees of freedom control, especially for the humanoids that have demanding needs for balancing, for collision avoidance, plus additional tools that are really helpful for the development, Move It for motion planning of the arms. Then the quality, so GitLab for control, version control, Jenkins for continuous integration, and more high-level perception-oriented libraries, OpenCV, PCL. We saw all of this getting matured thanks to the community in robotics. Especially PCL was actually one of the, let's say, spin out of Willow Garage. Move It the same. Orogos, it was an open source project that actually we baked. We put money on the development of it because it was super nice, and it's something many of the ideas that are nowadays present in ROS 2 were already present in Orogos more than 10 years ago. All the component base, the life cycle of software nodes, the inter-process communication, the modular combination of software module for building an application was super nice, and we are still using it. So actually, we're now using Orogos in combination with ROS control inside ROS. So it's at the end, it's like a multi-layer structure, and each one is serving one specific purpose. But understanding that was a long trial and error process. And especially ROS control, for those of you that are not familiar, this is more technical and more low level, but it's something that is helping us a lot because we have many different robots. And we don't want to reinvent the wheel for each one of these. So thanks to ROS Control, we can share a lot of software, a lot of code in between among the different robots that we have. ROS Control is the lower layer that abstract the hardware to the, let's say, ROS ecosystem. So all of you that have used the simulation, actually ROS Control is something that we put inside Gazebo so that you can use then joint trajectory control, you can use a navigation stack, you can use Move It, and that is because ROS Control is basically creating an abstraction of the robot in which you have resources that can be sensor or actuators in a standard way. So every controller then access the resources without knowing what's below. And you don't need to know if the communication bus is CAN bus, is EtherCAT, is serial. That is abstracted thanks to ROS Control, plus additional feature that you have introspection. You can stop dynamically controllers. You have parameters, you have dynamically configure of parameters, PIDs, whatever. And actually, this is something that also I think now is, let's say, a little bit of inspiration for new idea, new project that we have. Especially ROS Control also was born thanks to some of the collaboration that we had in European projects. We have at present many ongoing projects, and we started since I remember the first project was an FP7, then H2020, then now Horizon Europe. And why we started the European project from one side, because we wanted to be involved into R&D projects with partners in Europe in general. From the other side, because we are then providing hardware platform. So there is a need also in this project to have a supplier of technology or to customize the existing technology with new features, new sensors. So we wanted to, let's say, from one side, be involved for being able to develop our own ideas in R&D project backed by Europe. But at the same time, sometimes we need the expertise of someone else. So maybe even for technology transfer, we know that a partner university has a nice technology, but they don't find the application. So, okay, we say, okay, we need that technology because we do have the application. And that is an opportunity for a project proposal, a consortium creation. At the moment, in Factory in a Day, for give you an idea, that was started in 2013. And partners of this project were Materialize, I don't know if you know it, is a pioneer in 3D additive manufacturing. Now they are multinational, they have location all over the world, and they were basically one of the first, it's called the Service Bureau. So now they are one of our main supplier of 3D printed technology. They are pioneers because they started using 3D printing in medical application, for instance, for for dental surgery. They do in 3D printing support that help the surgery. They do also for spinal intervention. So from the medical point of view, they are really in cutting edge technology, especially with the material innovation, because for this type of application, it's special material that are non-allergenic, that are, let's say, so they use a lot of special materials, plastic and chemicals for that application. At the same time, they invested a lot in fashion. So now they offer services for designer, for fashion stylist, and they offer like customized glassware or even for furniture. So there are all a market of 3D printed furniture and accessories. And one of the other partners that was in this project is Universal Robot. Universal Robot, that is now one of the main manufacturer of robotics industrial arm, started this project. I think they were like 100 people. And during the project in 4 or 5 years, they grew more than 10 times. And they now, I don't know, that they have like a production capacity maybe of 30,000 units per year. And we saw this in the project. Actually, the project was about how can we use robots and software to set up an industrial application in one day. And in this project, we developed ROS Control because we believed that was a core components for allowing reuse of software in control. But also a lot of attention was paid about the simulation, because if you know the layout of the factory in advance. You can make simulation, you can simulate the layout, the work cell and the pipeline that the manipulator have to use inside the factory is also something that you can simulate. And that helps a lot, because then you go there, you assemble the robot, and that's it. You need to calibrate, but then the application is already validated in simulation. And all of this was done like inside this project. That was the first European project that we got. Then more in the service robotics field, we had this project Grow Me Up that was kind of ambient assisted living robot that was a support for people that was, let's say, in a house domestic environment, so that the idea of, thanks to robots assistant, maybe you can make people more independent. You can provide supervision, monitoring, and you can make the people, I don't know, be longer independent at their place before going to hospitals or to residents. Then other project, also this is quite interesting in healthcare environment, in which we are thinking of the robot as a tool for caregivers to serve multiple patients from a remote location. So the idea of, let's say, supervised autonomy, or the possibility that if there is a need for the robot to do a complex task, the caregiver can actually teleoperate the robot with like a nice like a docking station, when you have different sensor, you have haptic device. One of these, for instance, is visible here. So actually, this idea also here, we started maturing the idea that we need to have force control and force feedback, especially if you want to do interaction task. So we started thinking, okay, we need to have a force torque sensor in the wrist, and we need to make the operator feel what the robot is doing in the environment. So imagining here, we were trying to simulate the operation in a kitchen. So the robot that has to open the washing machine or manipulate objects, the operator, that as the robot is not yet able to do that autonomously, the operator can help, but the operator needs to understand very well what the robot is doing when interacting with the environment. So we started adding, you see sensor on the robot, like tuning Tiago, like a prototype and rapid testing of different technology. But it was nice because this guy is one of our partners that is in Delft in the Netherlands, and there they have this need of they don't have enough caregivers for all the population that is aging and so on and so forth. So they're really interested. Actually, one of the, let's say, also baker of this project was the National Security Agency in Netherlands, because they believe that this is something that we need to spend money in, to try to make a robot that are helping reducing the cost for the social security, because it's a cost for the society in general that someone cannot be more independent. So they have this vision, and we share this vision. And actually now I think this was the first project in this direction, was Sacro. Then we had Sandro. Then now we have Sandro 2. So actually it's not only one project that we have normally in this type of application, because with one project, 2-3 years, you cannot do nothing. So you need to have continuity. You need to create technology, then you can build on top of that technology new results and understand, make mistake. And that's a little bit the philosophy, that one project doesn't end after the project. And if there are good results, we can exploit them. If there are no good results, but you learned a lot, you can then create a new project based on that lesson that you learned. And this is a little bit the philosophy. Actually, that is exponential. For this reason, we started with one project in 2004. And at the moment, I think we have 20 projects. Yeah. And it's complicated. It's complicated because at the end, you need to have clear ideas about what to do. Now, I don't have clear idea about how to stop this one. Can I? Okay. And also then human and robot in social application. This was more, let's say, cognitive social behavior, like understanding the intention of a human and trying to imitate with a human and robot in interaction task with the human, especially for patient or problems in cognitive problems with people. And one of the also good results of, let's say, this initial European project and collaboration that we had was that we understood that there was the need for mobile manipulators platform. And that is something that we were not the first understanding this. Willow Garage, they had the PR2. That was the first, let's say, service robot as a product, because they also not built many units. They distributed the unit to several universities in the US and in Europe. They had a lot of really good results because the robot was able to make autonomous navigation, move it for motion planning. They had the application of folding clothes, cleaning the kitchen, cooking. But then Willow Garage disappeared because of the funding problem. Many small spin-offs were created, but there was no, few of them were able to develop a robot that was able to do autonomous mobile manipulation. So with Thiago, we started with this idea in mind. Okay, can we build a robot that is, let's say, affordable, that is mobile, and that can do manipulation? And we actually interviewed many researchers, many professors, especially Europe, people that we knew, people that we found at conferences and trade fairs. So actually, Thiago is the result of like a survey in which people try to give us the ideas about what a robot like this could be. And at the beginning, it was difficult because, I mean, we didn't have a robot of this size. We managed to reuse some of the technology that we had in previous robots, especially for the arms. But then the mobile manipulation is something more complicated. You need to have a small footprint, but then you need a robot that is stable. And then you want to have many sensors, but then the sensor need to be powered. That reduce the autonomy. So we try to combine this and make the good trade-off for a platform that was accessible, easy to use, ROS compliant, and that the potential to do complex tasks. And then the result was quite astonishing, because maybe the robot is not the nicest robot that we have ever built, but it's true that we used it in so many applications that is unbelievable. Because I've seen universities that have used it in competition, industrial partner that they used it in industrial application manipulation for automotive industry. We have seen application in domestic environment for assistive robotics, and it's super nice that a single robot could serve so many different applications. That's a little bit the philosophy of the service robotics. We don't want a robot that is specific for one single application. We want a robot that is let's say, complicated enough, and at the same time simpler enough that is affordable, and it's the software, or it's the, let's say, the special maybe sensor that you are adding that is making it suitable for different applications. And this is very good. Actually, today or yesterday they showed me that now there are statistics about the most used open source simulation in the world, and Thiago is second. So the most downloaded in the world, I think is Turtleboard is third, and first one I don't remember now. I have the graph, but it's because it actually is the ROS2 open source public simulation in Foxy. Thiago is the second one, and the first I think is I don't remember, someone from Open Robotics. I don't remember which simulation. But so for me, it was astonishing, because it's something that actually now you don't expect. But now there are universities in France and Germany that are using Thiago as let's say, the standard robot for the robotics course in simulation still. But also this, for us, it's quite an impressive result. If we manage to accomplish that the robot is, let's say, interesting enough that you can do a robotic course around it, even if it's for free in an open source simulator, is already something, let's say, that we should be proud of. And then one of the main characteristics of Thiago is the high modularity, or let's say configurability. Actually, this is not even complete, because now we have an additional base with omnidirectional wheels. Then you have several configuration for the head, for the torso. You can have one arm, two arms, the touchscreen, and especially for the end effector, we have several configuration. We have much more components. Also, we added recently the robotic fingers, the vacuum suction gripper. So this is a little bit also the strength and the complexity of Par Robotics, that as we do everything in-house, we can modify the robot as we wish, or at least as we can. And this is something that we can do because we do mechanics, we do electronics, we do the software, we do the aesthetics. Also, we have a little bit of everything in the company. So this is something that is quite special and is a strong selling point compared to other competitors. These are now the configuration. These are, as I told you, is the latest version, so with the omnidirectional base and 2 arms. That is getting a lot of interest and attention, especially because for mobile manipulation, having the possibility to move without, let's say, autonomic restriction in any direction is something very convenient, especially if you can combine motion planning of the upper body with the mobility of the base. And then competition, another big, let's say, also part of the success of Tiago is because of competition, because what we started doing is we started providing the robot as a standard platform for several competition. That for us was like a big challenge. On one side, we had to basically build robots in advance, teach or at least train different groups from all over the world to use our robots, and then assist them during the competition. That was even harder. But we started doing this. It was nice because then there was some nice story. For instance, there is in the RoboCup at home, there is a very nice group of research in Koblenz that then with their Tiago, they traveled all over the world. They went to Japan, they won in Japan. They went to US, they won in US with minimum support from our side. So actually they started with our help, but then they actually reached the result that for us were very difficult to understand. They had the robot fetching beers from the fridge. They had the robot cleaning a toilet in Japan. So it's super nice that, I mean, students, researchers and then also in IGRA, they had the mobile manipulation challenge, in IROS, the Shiro project. So there are it's very nice. I know for those of you that have participated to hackathon or competition, it's something that is really incredible that in few days, many hours, but few days, you can start from a prototype on ideas, the early implementation, and then testing. And it's amazing what, let's say, different people collaborating together can do when they work closely and really focus oriented in a competition. And I think that this is something that is super nice also in robotics now recently, the DARPA challenge, the Space Robotic Challenge of NASA. So there are these initiatives that thanks to the competition and thanks to an appealing price, they motivate people to go beyond let's say what would be possible without a clear deadline and rules and competition among different teams. So I think that also this is something that is now becoming very, let's say, typical of robotics. Now we have seen in ICRA, there was the team from ETH Zurich together with Robotics that they showed the subterranean challenge of DARPA, and they managed to have quadrupeds navigating autonomously in subterranean environment. Really amazing. A team of 3-4 robots coordinating together with limited visibility, with the problem with networks, and it was crazy. I think that we are really starting to see interesting, let's say, level of autonomy and shared autonomy that is becoming mature enough for deploying real robots, complex robots, not only Roomba in the environment. And mobile manipulation is the next challenge. For this reason, we are, let's say, betting a lot on mobile manipulation, especially on articulated robots. We are still interested in humanoids, and we believe that the mobile manipulator of the future will have, I don't know if only legs, but at least should be able to traverse more complex environment than the one that we are taught for mobile robots. So at the moment we have this, let's say, very different family of robots, the Tiago robot, mobile manipulator. Then we have HRI robot that we are focusing mostly on social application, human-robot interaction, expressiveness, emotional content and communication. But there should be some let's say, convergence of these two lines of ideas in the future, because at the end, a service robot, as I told you before, is something that is complex enough and flexible enough that it can be used in many different situations, depending on the environment, depending on the people and the interaction. And now, I mean, about suggestion about if some of you want to start a robotic company, I think that it's complicated, but today I think it's easier than it was 20 years ago, because we have, let's say, many examples already of successful stories. Recently, also today, or yesterday, Amazon announced that they have a new generation of robots. So actually, I think I was in the university when Amazon bought Kiva for almost 1,000 million euros for autonomous an AGV for the warehouses. Now they announced that they have a more advanced mobile base that also can navigate among humans, because they had this issue that the Kiva system, for those of you, is a mobile base with a lifter so that they move around shelves in the warehouse, but they couldn't share the environment of the Kiva with the worker, because the Kiva is blind. The Kiva is only looking at markers on the ground for localization, so it doesn't know about humans around. And they have this limitation that they have for the humans in one part for doing the picking, and the robot for the other side for moving around the shelf. Now, for bridging this gap, they develop a new robot that has more sensor, more capabilities, more functionality to share the environment with the human. And that is the big challenge that also we need to understand how to effectively share and how to empower humans with this type of robots. So I think that the challenge or the tips is that I would like to have a society in which robots are becoming tools, not machines that they are independent from us. So they should be controlled. There should be a tool that we use as we are used today, the mobile phone. You can have better connectivity. You are always in contact with, maybe even too much, but that is also a trade-off with technology. You need to understand how effectively use the technology and not to be used by the technology. So I think that we are in this process in understanding what are the potential benefit of a society with robot that can free us from many boring tasks, repetitive tasks, but not only in the industry, in our daily life. Cleaning the house is the dream of every of us. That you don't want to do the house chores, or shopping, or even for especially for communication or for extending the self. All this need of in medical application, the surgeon that is 10,000 kilometers away from where the operation is taking place, or exploration, or rescue application. This is something that is getting real, and is already real in many applications, because we have seen already a lot of this type of robots that are working. But then it's still missing the closer, the technology that every one of us every day can use. I think we are bridging that gap, and my suggestion is that you need to be open to new ideas. You need to look outside of the box for ideas from other fields, especially for us, electronics, quantum computing, blockchain. There are so many technologies nowadays that the potential of really integrating many different technologies is mandatory for robotics. That is a transversal field. You cannot do robotics without software. You cannot do robotics without mechanics. You cannot do robotics with materials. You cannot do robotics without cables. We really need to, from one side, from mechatronic point of view, there is still a lot of challenges to solve, but especially from cognition or software, we need to have robots that are more intelligent and more easier to program than what they are today. We are doing exploration, in visual programming, in speech recognition, in chatbot. But for the moment, they are still a little bit isolated pieces. We are trying to make them together and help for sting us in having robots that are easy to program for any event, any application, any demonstration. And on the time, the next step is that the users need to be able to use the robot and program the robot themselves, because the robot are at the end are like they are machine. They need to be continuously programmed. And I don't know if they can really do this without us changing a little bit our mindset and getting a little bit away from the code and a little bit more on a different perspective, more user-centered or more, I don't know, maybe more naive in this sense. And then for sure, I mean, as you may understand, that service robotics is not a job that we can do alone. So for sure, a rich network of partnership and collaboration is still mandatory. And we cannot think about getting isolated in our room and design and build the best robot of the world. We need to get out, to understand, to see what others are doing, to ask for help when we see someone that is better than us. And especially, I mean, we are continuously doing mistakes. So the mistakes are the, let's say, first step to learning lessons and to improve. And that's it. Sorry. Yeah, something.
If you have any question, maybe we can fly.
I actually have one question. Can you go back to the
Which one?
just before the final slide?
Sorry.
Okay, so here you also mentioned it. Consider open source code, but for starting of the company, if you go open source right from the beginning, then I mean, if your idea is innovative and it has a value, chances are like there are competitors that would like to use the same code or the same structure or achieve the same result, and maybe have already some platform. It's how would you cope with something like that?
Yeah, no, that is I understand that it's let's say a delicate problem, no? What to put the limit about open source, and especially because we are not, I think as a society, we are not yet ready for open source. And it's true that I would say also there is something that is now getting a trending topic about sustainability, about I mean, I would say, I don't know, of 100 startups, I don't know how many of them reach no, a maturity level or to commercialize the product they have. And also, like now I'm starting becoming more, maybe, you know, getting older, so starting to think about, you know, what I will leave to the world when I won't be here. So if the source is the open source at the end is gonna be your legacy, your I don't know if I understand it, but the problem is that I think that especially in robotic, software is not alone, is not everything, and then the open source actually can help in speeding up the development, because if you can get feedback, you can get contribution from someone else, actually you can go faster than you would go alone. So, and then especially if you want to improve, there is no better way to show what you have. Now we started a few years ago that the code reviews, and to enforce that people confront each other on the code, because at the end is I don't know. I mean, there are examples of brilliant coder that by themselves can do amazing software architecture, but I think that if then nobody else can use the software, that there is no value. So in that sense, yeah, there is always the worry that I'm gonna put this open source and some Chinese company is gonna copy the code. It's true, there is, but even without you publishing, that they will copy the same.
No? Maybe another thing to add on that topic. I think one of the best examples in robotics is ROS. ROS was created by Willow Garage at the same time as PR2. On one hand, it has been extremely successful for Willow Garage, but for the whole community, and putting ROS open source has created tremendous opportunities for hundreds of companies, including ours, to thrive and develop themselves. Now, on the other side, of course, Willow Garage disappeared. It's not only due to that, there is other reasons, but it's an interesting trade-off. So in that sense, Willow Garage left an incredible legacy with ROS and with PR2 as well, but ROS is still something that we actively develop, but it was a choice for them that had consequences. They could be replaced because they created technology to be easily replaced, essentially. So that's an interesting one. And I told you yesterday about ROS for HRI, and with Luca, we've been discussing a lot about that. Should we make it open source or not for HRI? Currently, there is not many companies, or actually there's no companies, the ROS ecosystem at least, that have this kind of complete picture of how we're going to deal with this. I think we both agree that it's actually beneficial for us to push that large part of the open source, because first it makes it possible for all of you to contribute and to use it and to provide feedback and to improve it, but also is a way for us to establish ourselves as, publicly establish ourselves as the leader of that technology. And if we keep it for us, then maybe we are the leaders, but the leaders of something that no one knows about. But if we are the leaders and we put it open, then we are the reference point. But there is a risk. It might be the case that tomorrow.
No, but then there are several possible outcomes of open sourcing. Not even all of the software, part of the software that even if it's critical for the company, like could be the ROS for HRI. So that could be someone that completely copy and use and make profit of selling robot with a piece of software, but then you are not competing only on the software, you are competing on the whole package, no? You are competing on, I mean, if it's open source, they cannot only sell the software because the software is going to be available to them. Then one thing is the open source and one thing is the licensing, but that is a different story. But okay, so can be open source, but could be not for free. But that is another story. But then even if they, so there could be a portion of, let's say, people that are gonna simply copy and use the software. Then there could be another portion that they use it, but also contribute to it. So that in that sense, no, you grow the user base of that piece of software, you add more features, you fix more bugs than you would do alone. Then you can also create, let's say, opportunities for business in that, because that could be someone that looks at that and say, but Robotics is the maintainer of this service, then maybe they can add this feature and we can say, okay, we're going to add it, but maybe we need to be support in terms of maintenance, no? And then the visibility. Then you put the hat of, okay, I'm a supporter, I am maintainer, I am a developer of this type of technology, so that you get acknowledgement, you get, no, that this is creating momentum, and it's attracting also talents. I think it's a big effort because it's not for free to put the code open source, because you need to be aware that it doesn't come for free. You need then to be present. You need to respond to merge requests or to issue in the public repository. But it's something that I think it's unavoidable if you want to get known and if you want to really be open and understand how to improve the things that we are doing. Because otherwise, if you are closed in your room, you are always the king of your room, no? So I think it's challenging, because at the end you need to have time for it, and you need to be ready to give away some of, let's say, the IP or some of the ideas that you have there. But also I think it's a good strategy for growing as a company.
There's a concept that I found really interesting in open source called commodization. So because, like, we take the example of Ross HRI, because a company like PAL, as Luca said, that develops other things, says, oh, the human detection, you have it for free. We are kind of destroying the added, we are removing a lot of the added value of that. For us, it's fine because we are selling other things. But if I were a company selling only people detection, suddenly my business has no value anymore. And big companies, not in robotics, but big companies like Google, like Google is one of the best examples. Google is extremely active in the open source community, but they don't do that just out of generosity. They do that to kill everybody around, saying like, oh yeah, we don't care about. So Gmail is an example of open source. It's free. The day they did that, all the businesses that were trying to sell online webmail disappeared because they have no value anymore. And you can apply that to a lot of the open source technology. So it's a bit of the evil side of. Well, the way I describe it sounds a little bit evil, but it's also true that, so yes, basically by saying that, oh, this part of the technology is something that we want everyone to be able to use for free, should become the baseline on which you can build. We are commoditizing that value, that part of the value, and that's something we can do, and that's something that has an impact on our business as well, because we cannot eliminate by doing that potential competitors that could only offer that category. I don't think we're doing it for that purpose because I'm not aware of any competitors doing that. But that's part of the reasoning behind also sometimes deciding for a company to open source their part of the stack.
You mentioned a lot of, basically you started from a mechanical point of view, the robotic design, and then you move to software and included more and more components. We saw many robot designs, but no reference to software. So I'm not very sure if by software you mean only support, or you develop maybe some state-of-the-art ideas that you include in your robots. And as a follow-up, who are your competitors? Companies who design robots, software?
Okay, so first thing, a software example. I mean, our robots, then there are different functionality, different, let's say, component, but the most, let's say, common ones among them is that for each robot, what we provide, let's say, a set of basic functionalities that then the customers can test, use, build on top of them, or they can even replace with their own controller. So in terms of, let's say, mobile manipulation, we provide the robots that are already able to do some grasping, perception, recognize object with point clouds, or with different RGB images. We do the mobile navigation that is not only the use of navigation stack of rows, there are some additional, let's say, additional component that we built on top. And what else? Then we have I know, more complex controllers for the arms. For instance, we have what we call whole body control. That is this is a big chunk of software of us that we are using in all the robots, more or less. But it's something that, for instance, we use on the humans for having a robot that is able to balance, to walk, and to coordinate the upper body motion in a, let's say, hierarchical way. So it's like you have a generalized inverse kinematics algorithm with priorities. And this is something then is a little bit more interesting, especially for humans, in which you have much more degrees of freedom and you need to care about falling down. So you would want the robot to stay always balanced on top of the footprint. And especially if you want then combine tasks like grasping an object and keeping the gaze of that object, you have this type of, let's say, hierarchical and prioritized task planning. And this is something that also it's helping then in abstracting a robot and programming the robot from a higher level point of view. Because so that you don't care about which joint to move how much or which sensor to use, you reason more in task space. So you say, okay, I want the robot to move to the table, and I want the object to be grasped, keeping the orientation constant. So there is a different kind of, let's say, programming that you enable using this kind of framework. And this is something that we did, that we are doing it in ROS control, because this type of control and need real-time capabilities, because they are optimization algorithm running at, I don't know, 1 kilohertz, 500 hertz. And then what else we are doing? We are providing also ROS for HRI. So it's an example also a framework that we are trying to build, in which there are, I would say, different modules. So you have the face perception module, the skeleton tracking. You have also tools for visualization that you can use for improving the understanding of the system that you are building. And what else? And then also from more, I would say, user's perspective, we recently started giving a lot of attention about graphical user interface or way of programming the robot in a more, let's say, simplified way. So especially for ARI, we have all this kind of, I think that there was an image before with kind of architecture of the software. It's called what we call web GUI. That is, so here is a little bit the architecture software that we have. So Ubuntu and ROS are, let's say, the common one. Actually, we have then a layer that we call normally PAL something, PAL Ferrum, PAL Gallium, that is kind of our set of packages that we install on top of the typical ROS distribution. And here you have an example of different, let's say, packages of functionality. So you have the low-level one that are more, I would say, driver-like. So at the end, we need to provide driver for accessing the hardware, the sensor that we have on the robots. So depending on the hardware configuration, you can use an open source package, or you have to write your own driver. And then you have more advanced, let's say, libraries. So in this case, for instance, for SLAM, we can use Orb SLAM, or we can use our own SLAM, or you can use Carto, you can use different one. We also give the possibility to switch between different software packages. And then you have the MoveIt libraries. In this case, also here, you have more perception-like things or things related to speech. So we recently started using Google chatbot, Google speech recognition, but also we have our own or open source solution that are offline and doesn't require a cloud access. And then we have this, let's say, these two high-level blocks that is our web-based, because one of the main limitations that if you want to use the robot, you need to have a laptop with Ubuntu 20, with ROS, so it's starting getting not that easy for a normal user to access the type of technology. So we have different, let's say, web interfaces or web tools that allow the robot to be monitored or to be programmed. So the web GUI actually is a collection of different tools in which we have the motion builder that is for creating new motion. We have the touch web manager for ARI that is a content creator for the touch screen. Then we have the task scheduler, task job manager, in which you can create different tasks and schedule them in time so that the robot can navigate to a point at a specific time of the day. Then you have the navigation plugin that is for creating the map, editing the map, and creating the routes for the robot. So all this basically is not even ROS. It's something that is accessible from a mobile phone, a tablet, or a laptop, and it's something that's more, I would say, user-friendly than coding in Python or in C++ or in Bash or whatever the robot. And it's something that we need to improve a lot, because at the end, also in this case, you really need to have users using the tools for understanding what's missing and what's too complicated to understand. But it's something that I think, especially for Ari or for Thiago, is something that we need to improve a lot, because at the end, the majority of the user, they don't want to mess up with the code. And so it was.
I am very interested in the way you try to develop robots that are high voltage of customization, which is able to users' needs, especially Tiago. I mean, as I have worked with customization, I think it's a different candidate for my work. And I was wondering about what would be, for you, what would be the next step of customization with that kind of robots in terms of features that could be customized, or degree of involvement with the user in what kind of stages? What could be next step of that, and what would matter? Why would it matter?
I mean, we actually, one of the ideas that we had at the beginning was extreme modularity. So we actually thought especially about actuators that could be modular and everybody could assemble a different way. But then we failed to commercialize actuators. Then there was an initiative from a company in Spain also, that I don't know, then was even baked by Sony. They were thinking about this concept of HROS. I don't know if you're familiar with it. It's kind of hardware ROS, so that ideally any components could be a ROS components, or being it an actuator, a sensor, a computation module. And then you can plug everything together, and by magic you have the URTF, you have the everything connected. And recently, actually yesterday, I was in a fair in Munich, and there is a super interesting company that is called Robotics. It's a spin-off of Tube, and they have this concept of modular manipulators. So they have a set of actuators, a set of links, and a computation unit, and you can plug together the system, and automatically the system discover itself, create the URDF, and you have the robot running in minutes. So from let's say engineering point of view, I think that the extreme modularity and the possibility to reconfigure the robot quickly from both hardware and software point of view is something that is not yet so easy to do, apart from exception, but it's something that we are doing basically knowing the components and having many configuration possible. For instance, I don't remember, imagine in Tiago, I think the configuration file for movie, there are like more than 300 different files. So we are doing the brute force approach. There is nothing, let's say, automatically generated at the moment, but we have all the pre-programmed configuration, and we pick up the right one. I mean, we are starting thinking about the evolution of Tiago as a mobile manipulation platform in general, service robot. So I think that there is a little bit of, let's say, you need to be ready to add new sensor and to have the possibility to easily customize the robot, because the technology is going so fast that you cannot decide, okay, today I want this sensor and I'm going to use this sensor for 10 years in production. We are not at that stage, or at least we don't want to be blocked by the choice that we do today or we did yesterday for the next future. So from one side, we still believe that modularity, at least from mechanical and mechatronic point of view, is fundamental. Then from a sensor point of view, it's true that you don't have yet the perfect sensor. And for the moment, it's a combination of sensor and depends a lot on the application. If you want to use cameras, if you want to use LiDAR, if you want to use force sensors. And the idea is that also in that sense, we want to be able to have a platform that is flexible enough and we can explore different ideas. For the reason also from the, let's say, the configuration that we have on Tiago, we started adding new feature. The omnidirectional base is one example. Now we are also developing new arms for the robot that have better, let's say, capabilities in terms of sensors, because we are going to add also force sensors and torque sensor in the joints. Then from a sensor point of view, now 3D cameras are now the let's say commodity, and we believe that maybe more 3D cameras is going to be an added value, because you have really dense information, you have images, you have 3D information, and at the end I think that is you need to also think about not only the robot, also what is outside the robot, no? And so the perception of the self-awareness is nothing without reconstructing what is around, and especially also with Severen in ROS for HRI, they have this now they are trying to formalize, to standardize the way a robot perceives a human in terms of multi-sensory description. So you have the face feature, you have the skeleton tracking, you have the voice. So it actually is a little bit, I think the sensor fusion is what is missing, and how to treat all this amount of information in a standard way so that then you can reason on top of that. So I think that at the end, you need, from one side, it is important how to synchronize and how to merge all this information from sensor point of view. So it's not only important where do you put the sensor, but also how you mix, you fuse the information of that sensor with the other one that you have. And I think that for the moment, what we are trying to do is to think about, okay, the robot, for sure, we're going to have a sensorized head, but then also we want to have as much sensor as possible on the end effector. Because if you want to have rich manipulation, you want a tight sensor. If you want to do visual servoing for grasping, you need cameras on the end effector. And especially the force sensing is something that we are investing a lot of effort on, because we already started with Talos. So Talos is one of the first robots that is fully door controllable. And this is enabling us to do way more complex things than just walking on flat terrain. So the robot can adapt, and we want a robot that is secure, safe for humans. So especially in case of collision, in case of touch, we want to know where the contact happened so that the robot can stop, can plan, and can avoid doing any damage to the environment, to the persons. So I think that we're going to have much more sensor than what we have so far. Actually, I would like to have skiing. I would like to have more way to make the robot aware of what is going on outside. Now we know quite well what is going on inside the robot, but we still lack sensor or technology or the right algorithm to process those sensors to create a real self-awareness, not only introspective, but also respect the environment where the robot is going to work.
And are you considering this modularity, just about the software and the hardware, to be more and more user-friendly than the end user could have a full hand on even on robots? I mean,
yeah.
Yeah,
we already started with Thiago. Actually, we have customers that they can swap the end effectors. And I hope that also we could be able to have a robot that can easily be changed from one arm to two arms. Or maybe, the base, you can have the different configurations so that actually you can combine the robot quickly. That is, it's complicated at the end because there are no standard interface for this type of technology. So all you need to design your own standard and then hope that it's not going to be obsolete in a few years. But I know that, there are some examples that this has been is possible and is successful, but it's still not so common.
You were just mentioning now collision, injury, and so on. So going back to the business operations as well, that specific aspect, how do you deal with liabilities in that sense? Are you insured? Have you managed to find an insurance or?
Good point. So most of the robots that you have seen, they are still research platforms. So actually they are not, let's say, certified, CE marking, whatever. So they are normally used in research activity so that you don't need to go through this. For the mobile basis or robot that actually we are providing as a commercial platform and product, we have certification. We have gone through this process of certifying let's say, the safety level of the robot. So especially for the mobile basis, the sensor that we use or the shape of the robot or the speed of the robot are such that they are not causing damage in case of collision, in case of an impact. But it's true, even recently for Ferrari, we had to redesign all the upper body for complying with an ISO about, say, pinching points, because the shape of the cover were such that you could put a finger, you can get trapped. So we had to redesign all the upper body and all the arms. So now I think we don't have it's gone. So, but the effect of that redesign for complying with this type of standards basically, as a consequence, we had to put out the touchscreen. So the robot now is the touchscreen external, and the shape of the cover is much more smoother, and there are no overture in the covers. And then, in terms of especially for the let's say manipulators, one of the risk or hazard that you have when you are close to a mobile manipulator is that the robot can collide with you during the motion. For HRI, we still haven't certified the robot as a collaborative or safe collaborative robot. We are going through this process of understanding what the maximum impact force that the robot can cause. So from one side, we are going to do experimental test trials in which we're going to measure impact to see really the amount of force that the robot can deliver.
So what are you doing tonight at the work? We need someone to do this.
Let's say you're looking to assess.
Yes.
And
there is no other way. I mean, there is the other way, that is the theoretical one. That actually is the one that I wanted to enforce. That I know the power of the actuator of the robot. I know the limitation of speed and torque of each actuator. So actually, I can mathematically prove
but
that the robot is intrinsically safe. But it's true that by the ISO, I think is the 1506 that the collaborative robot, actually they don't care about this. They say, depending on the point of impact on the human body, you have a maximum amount of force they can deliver. So even if the robot is really low power, there still can be a place, the head or the finger. So don't remember which part is the more fragile one in the human body, in which the level of force are really low, really low. So there are only two ways. Or you train every person that you need to use the robot. Please be aware that if the robot hits your eye, you have risk to getting blind. And that is something that even our customers, they don't want to do, because I will put the robot in the reception on my office. I have no time, I don't know way to train all the people that are going to interact with the robot for that. Or you limit the motion of the robot so that collision is extremely unlikely to happen.
Yeah, no, but my question was to go a little bit broader as well than this. I understand, it's quite straightforward in the mathematical assessing physical injuries resulting from a collision. But what about other types of injuries? For example, psychological harm that can be caused by the use of. How are you going to possibly assess that? Are you planning to assess that? And if you're not planning to assess that, how are you going to deal with the liability of that once it's commercialized?
I mean, not easy question to answer, but I think that that shouldn't be. I mean, for sure, you can make, before launching a product to the market, you can do user studies, you can do psychological assessment that the robot is not causing, but then also, I think that there is a limit, because especially as our robots are programmable. If someone, I'm thinking also a little bit more, imagine now someone can make the robot say whatever they want. Who is going to be liable for that? The manufacturer or the person that it's like the autonomous cars? No?
Yeah.
So that is still not clear also in autonomous cars.
At the end of the day, someone needs to be liable.
Yeah.
And if it happens to be you.
No, but I think, I think that from one side is like at least not the you need to consider the use of the robot, and you need to take care of making the robot intrinsically safe for not causing damage. And at the same time, you need to maybe specify clearly the normal use of the robot. And then I think that the owner of the robot should also be responsible for where the robot is used and how it's used. It's like, if you buy a mobile phone and you throw the mobile phone in face of someone, who is responsible? it's true that especially, as you're gonna customize the software running on the robot, you're gonna, program the motion, and you're gonna program who is gonna be the responsible in case of an accident. Actually, we have a new project that is starting now.
Oh, we had an accident this morning.
No. We have a new project that actually is about ethical assessment of.
The one with Sylvia actually on that transparency and it's I mean, the reason why for the context, Rocco is a lawyer doing his PhD.
I know. That's a super good point.
Yeah, no, but I mean, the whole point why you're doing your PhD project like PERSEO is to try to progress on those questions,
Yes,
because
exactly.
we don't have permit stuff.
I wanted some ideas from Luca.
One thing that is really, I mean, I love the point you're making about, okay, fine, contact forces that we can assess, but what about psychological harm? And the reality of it is we don't know. I think no one knows, at least in the robotic community, how to assess that, because we don't even know what would be the role of our robots in contact movements for sure, and we haven't less about how it will be perceived. However, just as a quick comment, we are also very well aware of that issue, and for instance, with Graphical and a few other colleagues, we are working on setting ethical guidelines for not only for how we are going to develop the robots, but potentially also how the users are supposed to use or not use the robots. It's completely foggy. I don't know where we are going with that.
I think yes, that's part of the interesting thing is that that's part of the issue, informing the consumer, informing the end user. But what I wanted to point to as well is the other part of the issue, informing the insurers. Because if you don't inform the insurers of what the risk could be, they're not going to insure your risk. So I think that should be the other side as well, a B2B side in a sense, which could be very interesting.
Are we insured, for instance, for what the customers could do?
No, we are insured for the robot that we have. For our robots, we have no insurance for the robot of the customers. Actually, is the customer that should. Normally, if they are university, they have universities.
I'm thinking of Tesla, for instance. I'm sure that Tesla is insured for the damage that what the user of the Tesla could cause to the company by misusing or maybe just using their car. So maybe, and I completely take your point, if we are going to a space where we control less, what can happen with our robots?
We need to protect ourselves from misuse or from.
At least think about it, and what are we going to do in that case? And what could happen to us in that case?
It's 450 pounds an hour.
Starting 3 years ago.
Yes.
Any more questions?
I have a last question. So Carl started with a big investment from the United.
Not big investment.
Okay, a small investment from the UAE. And as far as I know,
It was not even investment. Was they bought the project? They bought the robot. Actually, Rimei and Rimbi, they were not us. They were not ours. They were of the company that paid the development. We are selling engineering services.
Whatever. One thing that strikes me in fact compared to many of the other startups that you talk about is that it seems to me that we have very little external investment.
No external investment.
Yes. Is it so? I assume it's to a large extent choice not to look for external money. And can you maybe, for everybody, basically comment a little bit on what are the pros and cons of that? Because you were giving the example of universal robots.
Yeah.
Like, during one project they went from one.
Yeah, but because
1,000 people.
Because Teradyne put 300 million.
Exactly. But so why PAL will not do that? And is it a good thing or is it not a good thing?
Good point. I mean, we have discussed with Francesco many times. Now that would be super nice for him, especially, to sell part of the company and go to retire in a nice beach in
South of Italy.
exactly, or even Menorca or Mallorca, whatever. No, but the point is that it's really challenging to only depend on yourself, but it's also super let's say, the satisfaction when you achieve to grow a company like this from the effort of the team, the idea, projects, is something that has a lot of side effect on motivation. And then it would be super, let's say, getting funding and you start building, but it's super difficult to find. I mean, or you are Boston Dynamics, but it's I mean, for us, especially in this part of the world, it's difficult to find investors that want to invest in such, let's say, not so mature technology for scaling it up and for making it thousands of units or whatever. We have also the example of about the Baran. They had then they found SoftBank. They made many papers and now they are shutting down. So is that a little bit, I think, is the most concerning aspect of getting external funding, so that from one side that you are then you have let's say, I would say you are put in front of, maybe you have 2 years time, 3 years time to demonstrate you can scale up the business, can be profitable, or then you're gonna die. Then maybe it's convenient because the founder or the owners, so whoever the early employees, they can get a share and they can monetize that. But most of the time, at the end, you have a lot of injection of money, a lot of people start entering, a lot of different interests. You are not that freedom that you had before. And then you are forced to choose, okay, of the 20 things that you are doing, please do only this, because this is the killing the killing robot that is gonna get a lot of success. You invest only on that, and then you start narrowing, but then also you start closing a lot of opportunities, and then with the a possible consequence that the company is gonna fail. And this is something that, I mean, is not that the philosophy that we have been trying to cultivate here. No, is that okay? We know that we have a lot of passion and motivation in robotics. We want to want to decide by ourselves what to do and what not to do. It's true that the not having huge funding slow down a lot the growth or the possibility that you have, because you cannot invest that much in okay, let's do ARI 10 times cheaper because we can invest in huge production line and manufacture hundreds of units every month. We can do that. So you need to choose more with a lot of attention every investment or every decision that you do. But at the same time, you are maybe, if you do mistake, it's not a big deal. Actually, it's also a mistake can still be a good, let's say, a good point. And it's I mean, we have been having a difficult situation, difficult moment here, in which maybe the success or the continuation of the company was because of one project, because one delivery to a customer. That we still have this that we are continuing growing in terms of number of projects, number of units delivered every month. We are differentiating, so we have as I showed you before, different sectors, and it's something that is more complicated to do because you cannot focus on one thing. So that, I think, is one of the biggest challenges that we have. We are trying to do many things, too many things probably, but also this can give us much more possibilities. So we need to balance. We need to find the right trade-off in between, how many parallel things you would want to do, and how to make the right choice at the right moment. And this is, I think, also the good part, that at the end, there are not so many companies that do so many different things in Europe in general, and have let's say, the expertise or the recognition that Robotics gained in the last year. It's nice from one side to be small because you have then more agility, and at the same time it's also I mean, I was yesterday and the day before I was in Automatica, and then you have 2-3 companies spin-off from Tume, Agile Robots, and who else? In 3 years they have 300 people. They had a booth that was 20 times ours, and they had maybe 20-30 manipulators, and they have offering coffee, sushi. So they were like, okay, they have
next year. So that's fine.
Yeah, exactly. I mean, so I've seen many of these companies disappear in 2-3 years. So I think that it's more difficult what we are doing, because really you need to care about every cent that you spend, and you need to be maybe more open, to change. But still, you are still so you are maybe are not that rich, but at least you are continuously learning and continuously improving, and you are more focused on what is important and less on other topic. So it's I know it's especially I think this is the result that we are not based in Silicon Valley, or maybe it's a cultural one that we are more I know, especially Francesco is really he believes in this he want to be present in every decision. It's still it's not the CEO that comes once in a month, and then so I still every day I discuss with him about, okay, we need to hire one more person for this, and he's trying to make me explain why. And I have to convince him, if we do this, and maybe in 1 year we will have this result. So we are really trying to, every decision should have a motivation, and then we should check if that decision was right or not.
It's easier to negotiate with Francesco than to negotiate with your dean to convince him to open a new position.
Yeah, but I know.
We are not too bad. Brilliant. Yeah.
Thanks a lot.
I have a last question, maybe short. What do you think about Barcelona having, in the sense of robotics? Is the culture that is growing, or?
I mean, there are few. No, I mean, it's growing. I mean, the ecosystem of startups, especially in this area of the city, is growing. Especially, there are many startups, incubators about 3D printing, about IoT. Robotics also, there are few good examples. A spin-off of UPC that is doing actually they finished, I think, now the certification stage for a medical robot. There are one that is doing exoskeleton, and then there are many integrators that are using universal robot or mobile manipulators, especially for car industry. No, I think it's it's very nice. We have many also ex-colleagues that are now we have one, for instance, that is doing the construct is one of our previous colleagues that is doing on web simulation of ROS robot, and is doing a lot of also educational services. Another colleague of us, actually the founder now, is working in it's called Picnic, that is the company behind Move It. Then what else? We have another former colleague that has started a business about it's called my chatbot, but not chatbot as we are used on the robot chatbot, for instance, for automating marketing activities. So the chatbot in the website, or automation through WhatsApp for dedicated services. So I think it's really a flourish ecosystem. The reason why, I think also that Barcelona as a city has a good brand, so it's easy to attract. Also for us, it's easy to attract talent to come to Barcelona. So even if maybe the salaries are not that high as in other cities in Europe, you have the added value of being a nice city with the cool weather, and it is but I think that also there is this in general the city is very a pioneer in many things, as they are investing a lot in making bicycle lanes or car sharing and bike sharing, and it's quite technological. They are adding a lot of services also for people to make to rely more on technology and improve the quality or the speed of access to services in general of the public administration. So I think that, I mean, Catalonia in general is a rich region, and they have HP. They have been also having a lot of big companies that attracted the technology. HP here in San Cugat, they have let's say the R&D lab. The multi-jet fusion, the 3D printed was born here. Then especially for everything that is also related to biomedical technology, there are super important centers here. So I think it's a combination of factors, that you have a substrate of local, let's say, administration investment, companies that have been doing research and technology for many years, and now they also the need for young people to develop new things, and the lack of let's say the typical traditional jobs also motivated the initiative of small group of young people to create ideas behind with technology. It's nice. We are not, let's say, that I mean, we don't consider ourselves a startup anymore, even if for some, let's say, we are still a startup because we don't have yet a clear business model. We don't have yet a clear product that this is but it's good. I think that the ecosystem in general is helping us creating opportunity for new ideas, new projects, and it's nice.